So, welcome back after lunch. Hope you liked it today. And next we hear some talk from Max, which will talk about table partitioning in Django. Please enjoy.
Oh. Hi everyone, my name is Max. I am from Moscow, Russia. So probably some of you are wondering, like, what is this crazy Russian is doing here? I mean, it's a local German conference and everything is in German, and I don't even speak German and I don't understand German. So why I'm here? Well, because I love Germany, I love German people, I love German nature, and of course I love German beer. So I never miss an opportunity to come to Germany. That was a little introduction. Now let's get back to the topic. So, table partitioning with Django. The talk will be divided into 3 parts. The first part is about table partitioning theory. The second one is about implementation in different database servers, and the third part is about Django packages for table partitioning. So, the first part, partitioning theory. Let's start with the definition. There are actually a lot of different definitions, but I think this is one of the most simple ones. So basically, table partitioning is a division of one table into several tables called partitions, which still represent original table. So why do we want to do this table partitioning thing? There are basically 3 reasons for this: performance, manageability, and availability. So, performance. Suppose that we have a table partitioned by week, and a query requesting data for a single week would only have to access one partition instead of all partitions. Manageability. A system administrator could back up just a single partition rather than the entire table. And availability, imagine that one of the partitions is unavailable, so all the other partitions continue to work and your application still continues to work. So when do we need to do this table partitioning? Actually, it's a very complicated question because it depends on the application and you have to analyze your exact situation, but there are some common rules. So the first one is that if tables are greater than 2 gigabytes, they can be considered as candidates for partitioning. Then tables with historical data, tables that needs to be distributed across different types of storage devices, and if your queries always contain a filter on the partition field. So there are basically 2 methods of partitioning: horizontal partitioning and vertical partitioning. Horizontal partitioning is like when different rows are situated in different tables. And vertical partitioning, the idea of vertical partitioning is that different columns are situated in different tables, so it's very similar to normalization. There are 4 main partition strategies. It's range, list, hashing, composite partitioning. Let's have some examples. I took these cool pictures from Oracle documentation, so if someone is interested in table partitioning, I really recommend you to read this section in Oracle documentation, even if you don't use Oracle, because it's very simply explained everything here. So, range partitioning. It's like each partition contains rows for which the partitioning expression value lies within the given range. For example, date-time partitioning is a good example of range partitioning. Like you have a partition for each particular month, for example, or like here you have every 2 months stored in its own partition. Then list partitioning. Each partition contains a list of values that it accepts. So, for example, imagine that we have 3 partitions for East, West, and Central regions, and each accepts only rows with specific states. And hash partitioning is used primarily to ensure an even distribution of data among a predetermined number of partitions. There is also a composite partitioning, which is basically the combination of basic partition strategies, like you can partition your table first with the range partitioning, and then each of the subpartitions can be partitioned by another type, like list or hash, for example. So let's have a little example. Imagine that we have a table which logs user actions on our side. So we have a user 345, and first it logins, then it goes to the store section, then it orders a book, it pays for a book and logouts. So let's have a look at the SQL level of what's going on here. All inserts, in this example we use range partitioning and we partition by month. So every month a new partition is created, and all user actions for August goes to the partition for August, and all user actions for September goes to partition for September, and so on. But the cool thing about that is that if we do a select all from user actions, we will see all our user actions from all partitions. So this table partitioning is transparent. You don't need to change your code to work with partition tables. That was a quick introduction into partitioning theory. Now let's have a look about implementation. I will talk about two most popular database services, Postgres and MySQL. So Postgres, it supports horizontal partitioning method and range and list strategies. Partitioning is implemented via inheritance and is available starting from 8.1. Actually, it's very complicated to implement partitioning because there are a lot of steps involved. For example, we'll have a look at it right now, and you need to do 6 steps to implement a good table partitioning in Postgres. Now, step 1. At first you create your usual table. It's very easy, nothing special here. So then we create a partition for in August. It's also nothing special here, it just inherits from our master partition, and we add a check here, so we want only dates for the August. Now things starting to become more complicated because we need to write a correct partition insertion function. So the idea is that when you insert some data in your table, Postgres should automatically understand where, into what partition this data should go. So there is some dynamic SQL here, as you see. Then we should write a trigger that calls our previous function. It's very easy, just usual trigger. Then we need to write a function which will delete duplicate rows from master. I mean, I don't know why is this happening, is it a bug or a feature or something, but the problem is that when you insert a data into partition table, it gets duplicated. So it inserts it in the partition, which is a good thing, but it also inserts it into the master table. So the only workaround that I know is you have to create this function which will delete duplicated rows from the master table. Then we create a trigger which calls our delete function. And the last thing, the last step, this is the code for automatic new partition creation. So if you insert your data and the partition doesn't exist, it will be created automatically. So it's kind of complicated. You have to have a good knowledge of SQL to make this all work in Postgres, but if you have this knowledge, it's actually a very flexible partitioning solution. So now let's have a look at the MySQL. It supports also only horizontal partitioning, but it supports a lot of more strategies. All the strategies are supported. It has a native implementation of partitioning. There is a special partition by clause which you can use to partition your table, and partitioning is available starting from 5.1. Yeah.
Did I miss, you mentioned there are two types of partitioning, horizontal and vertical.
Yeah.
Did you explain what vertical partitioning is at all?
Yeah.
I missed it, sorry.
Okay. It's like when different columns are situated in different partitions.
Okay.
So it's opposite to horizontal. Now, MySQL, how it works. So actually it's very easy. As you see, you just create a table as usual and you add this partition clause. So in this example, we partition by range. So we want to create two partitions for 2012 and 2013 year, and the other rows will go to the partition P2, so they won't just get lost. But well, as you see, it's pretty simple, but actually there are some limitations. So first of all, speaking about this range partitioning, which we just saw here, the problem is that we can create partitions only from lowest to highest. So for example, if we want to create a partition for 2011, we can't just issue a clause, add partition for 2011. It will not work. There is some special statement, reorganize partitions, which you have to issue, and only then you will be able to add the partition, this partition. So it looks very simple how it works in MySQL, but actually there are a lot of things you also have to know about it. Also, you can't partition tables with foreign keys at all. If you try to do that, MySQL will just throw an ugly error at your face, and that's all. There are some workarounds, but they go just beyond the scope of this talk. By the way, speaking about Postgres, there is also a problem with partitions which has foreign keys, but Postgres will allow you to partition this table and all your queries will work, but you will lose these foreign key relationships, because foreign key constraint, it just looks on the master table and not on its children, so it will not understand that you have your records in your partitions, because the master table is usually empty. And also in MySQL it is impossible to create partitions in real time, because it doesn't allow you to have a dynamic SQL in your triggers or in functions which are called within these triggers. I also don't know why is that, but it just doesn't work. So the only way to create partitions is to use a scheduler in MySQL. Okay, the third part of our talk, Django packages. So I know only two packages actually which help you to work with partition tables. And this is not only for Django. I'm talking about Django because this is the thing I use a lot. But if you use Flask or something else, there are also no other packages available. So this is the problem. I don't know why it happens. So, okay, the first package, DjangoDBParty, it supports only Postgres, and it is written by the guy called Dan Fairs. The main feature is that it allows you to partition tables which has foreign keys, and in such a way that all your relationships will still work. So it's very easy to use. You just install it from PyPI or from GitHub. Then you add it to the installed apps as with any other package. And now let's have a look at the example. So I took this example from author's GitHub page. The main idea is that you have a tweet table and you have a star table. So star has a foreign key to tweet, and this is a problem. Then you create a tweet partition manager, and you just specify here what the current partition is and what the next partition will be. You add this tweet partition manager to your models and you make them abstract, and instead of the usual partition key you just use partition foreign key and it will magically work. That's all you have to do. Also it provides some APIs to get the data from these partitions, so it's very easy to use, but there is a problem here. So this is what happens when you use it. It actually doesn't use any real database partitioning, so it just emulates it. As you see, it creates just usual tables, and they look like partitions, but they are not, because they don't use inheritance. So this is, I think that this is not the best way to do this, maybe. So problems of this package: not database level partitioning, as we already said, no Django admin support, and no active development. I think that the last commit the author made was like 6 months ago, so I hope this guy is okay. Maybe he just don't have any free time anymore. So now DjangoDBParty, it's the second package. Actually, it's a package written by me, so it supports 2 database servers, MySQL and PostgreSQL. Its features are that it's real database level partitioning, there is an automatic new partition creation in real time, and there is a Django admin support. We already talked about that you can't use a pure SQL solution to create new partitions for MySQL, so what I did to implement this is like I did half of the things at Python level and half of the things at SQL level, because there is no other way to do this. So I just try to determine into what partition the data should be inserted, and if the partition is not exists, I just construct some SQL and execute it. So it works. It's actually also very easy to install, again from PyPI or from GitHub. You also add it to installed apps, and then in your models P file you just import something called partitionable, and you make your model which you want to partition, you make it to inherit from partitionable. Then you add a meta class to your model with a few settings which also should inherit from partitionable meta. So there are some settings here which we'll look at it a little bit later. And lastly, you just issue some command. And what happens here that it just creates some needed SQL and it just executes it. So if you remember about the Postgres problem, there was like 6 steps and a lot of SQL code to write to make this partitioning to work. This is what this package does for you. It just writes all this code dynamically, depending on your particular settings and your model. So it just makes you think that you are, a cool database architect and so on. And so here are the settings which are available. Actually, this package is very young. I made a first release, I think, in June. So there are not a lot of functionality, but currently you can only use range partition strategy, and only with daytime partitioning. I mean, you can't partition, for example, by zip codes or something else, but it will all come in the next releases. And currently you can partition by day, week, month or year. And this is, you can also customize how data will be displayed in the Django admin. So you also add an import statement in your admin PI file, and you make your model admin to inherit from partitionable admin. And there is a little settings here, partition show. So these are the values that it accepts. All partitions, that means that you see data from all partitions in the Django admin. Current means that you see data only from current partition. It means that, for example, if you create partition every month, and then you will see the data only from current month. And the previous means that you will see the data from the previous month. But also there are few problems with this package. So it only supports range partitioning right now, and only based on daytime, as I already said. And also because it's I'm trying to do everything at a pure database level, so there are some limitations that I face, but I will try to implement some workarounds for some problems in the future. So that's basically all of my talk. We did it very fast. So if you have questions, please.
You are fast.
Yeah.
Faster than expected. Yes. Any questions? Thank you very much so far. Question over there.
First off, thanks for the talk. And could you go back to the example for Postgres where you wrote the trigger, the one where you redirect into the other partitions?
Okay. You mean this one, or this
the one which inserts into the partition?
This one.
Okay, and this trigger is usually executed in before insert on the master table.
Yeah.
And if you return null there, it won't insert the row into the master table.
Yeah, but there is a problem with the solution that you want to implement, because there will be another error. I just don't remember right now which exactly, but I tried that. It just doesn't work. So you can try it. I mean, there was some problem with Django ORM, I think, because it just didn't like that you return none here.
Yeah, now that you say it, I can imagine that we are looking for the inserted ID, and we don't get it if we return null.
I think yes. This is was
okay. Thanks.
Okay, any more questions back there?
I'm not sure if you mentioned it or not, but does your solution work for any database or just for Postgres?
For Postgres and MySQL. I mean, not this specific trigger.
Yeah, of course.
The package, yes, it supports to database service.
Okay, thank you.
You're welcome.
More questions around? Anyone? Yes, Isaiah.
With the other package, you had to do a special thing for foreign keys. With your package, is this also necessary, or are foreign keys automatically resolved?
No, I just don't support foreign keys at the moment, but I will have to think about the correct implementation, because I just don't think that the workaround which this guy used is the proper one, because it's not the pure partitioning, it's just emulation.
Okay.
Can you turn to the next slide, please?
This one?
No, the one with the condition for the datetime field for the month.
This?
Yeah. Is that how you do it in your solution?
Oh, yes.
Okay. I think it should be added less than and then 1st of September.
Yes, it will also work.
Is timestamp only for full seconds, not for microseconds and nanoseconds?
Actually, I don't know about nanoseconds, so I don't know if it will work or not.
Okay, because I implemented this some month ago for log data, and then there were some at sub-second level that created errors when I implemented it like this.
Yeah, it's very possible. So maybe I have to look at it. So maybe you're right, because in some very busy systems you may lose some data in this way. Yeah.
Then it gets inserted into the master table.
Yeah. Thanks.
More questions? Doesn't seem so. Then thank you very much again.
Thank you.